Hello everyone, this is John from Vulgar Kitten Studios, and welcome to part 7 of our third-person shooter controller. This is the 7th and last part of this series. So basically all we need to do now, we have our controller moving around, we have our camera working and everything. It all looks really good so far. The only thing that we need to do is actually get our aiming to work up and down and actually follow our camera target. And we also need to be able to fire rounds as well, obviously. Well, there is one more thing that I noticed, is our head controller is not actually being a head controller. So before we get too deep into all of this, let's just go ahead and make sure that our player's head can look in the direction of our target. So we're going to go ahead and re-enable the head look controller and just expand this out. And right now it's asking for the root node of this guy and the target transform. So we need to use the hips, and we'll put the hips in the root node, and we'll use our player target for the target that we actually want to look at. And now we need to actually just set the segments of the controller that we actually want to be affected. And so we'll just make this a size of 1. And in our element 0, we'll go ahead and set this up for the head. So we'll expand our hips and expand our spine down and find our neck and expand that out to the head, and we'll use we'll use neck 1, or actually we'll just use neck for the first transform and head for the last transform, and we'll set up the values here. So for our blending multiplier, we'll set that to 0.7, and for our max angle difference, we'll set it to 30, and for the responsiveness, we'll set to 4, max angle blending we'll set to 25, and we'll leave the threshold at 0. And this should give us a desired effect. If not, we'll swap out that neck for neck 1. So let's go ahead and look at that, and actually it does look like it's working, so at least to an extent it's working. So yeah, we'll just leave it like that. It works good enough. And so now what we need to do is we need to actually set up our weapon system. And so we actually have 2 scripts for this. We have a weapon script and a destroy decal script. So I don't know if I've mentioned it before, but we're not going to be instantiating objects as prefabs, as for our projectile prefabs, that is, because that's actually terribly inefficient doing it that way. And you'll see if you have a large amount of projectiles in a single scene, then it can massively slow things down, sometimes even crash your game. And instantiating that many objects that are moving is just going to kick in the garbage collector way too much. You're going to wind up with many memory leaks. So what we're going to do is we're just going to use Raycast projectiles. So we'll go ahead and open up the projectile script, and we'll open up the destroy decal script. And let me just go ahead and come back in here. Okay, let me get rid of player animator. We'll get rid of player target and player camera as well, and we'll just put weapon over here, and we'll work with weapon first. Alright, so just expand all of this stuff out, and what we're going to do is, first of all, we'll need some variables. We'll need a public float, and we're going to call this fire delay. And what this is going to do is it's going to allow us to increment the amount of time that it takes for the player to be able to fire another shot after they fired a shot. And so we'll also need a public transform, and we'll call that gun rig, and we'll need a public transform for the muzzle. And this is going to be just an object that is in front of the gun rig, at which we're going to instantiate a muzzle flash and actually use as the center point for our projectiles. So we'll also need a public game object bullet hole, which is going to hold the prefab for whatever bullet hole we're going to instantiate at the point at which we actually fire our weapon at. And we'll need a public game object muzzle flash, just to give the rifle a firing effect. And we'll also need a public camera, and just call it cam. And we'll need a couple of private fields as well. We'll make a private float fire counter, and this is also used to dampen the amount of times that the player can fire. And so we'll also say private player controller, and that's going to be player controller, and we'll also need a private ray, and I'm just going to call that ray. And then in the start method, all we need to do is just set our player controller equal to get component and player controller. And sorry if you heard me burp, that just happened. So yeah, sorry about that. Anyway, moving on now, we're going to go ahead and come down here, and this is update, but we actually want to use late update because we're going to be rotating our gun and everything, and we want all our camera and movement calculations to happen prior to this. And probably, I mean, we could even do this with physics calculations and fixed update, but I'm just using late update. So we'll first of all need to create our array, and our array is going to be equal to cam.screen point to array, and we've already seen this in our player target script, but essentially we're going to do the same thing, and we're going to say that is going to be a new vector3, and we're going to say screen.width is multiplied by 0.5f, screen.height multiplied by 0.5f, just to get to the center of the screen, and 0 for the z. And that is going to be our array. And we'll say if our player controller dot aim, then we'll want to say gun rig dot forward is equal to our array dot direction. So this is actually going to rotate our gun rig to be in the forward direction of the array, and we might actually even want to lerp that. Why don't we try doing that? Let's say mathf dot lerp, and we want to lerp from our gun rig dot forward to our ray dot direction, and we'll do this over a certain amount of time, and we'll expose that as a float. And this is just programming on the fly. It's just an idea that I had, so sorry about that. So yeah, we'll just say lerp speed, and we'll make that equal to probably maybe about 2 by default, and then we'll say lerp speed multiplied by time dot delta time, and this is going to give me an error. So what we have, it's wanting floats. Okay. Alright, so maybe that isn't the best idea in the world. I will actually look at that for future iterations of this video, because we can't actually use direction, or we can't use vector 3s there, so we'll have to do some conversion business. But it was a nice idea, and we'll definitely get that smooth at a later point in time. But for now, that's what we're going to have to work with. We're just going to have to work with the snapping there. And if that's the case, then we'll do that. Otherwise, what we actually want to do is just set our gun rig dot forward equal to our transform dot forward. Okay, and then we'll say if input dot get button, not get button down, but get button, player input, and we obviously need to use our globals up here. So we'll say using globals, and we'll want to say player input dot fire 1, so our left click, and our fire counter is greater than our fire delay. And if that's the case, let's go ahead and see if this, yep, it resolved. Then we'll want to say muzzle.audio.play. Not play on await, but .play. And if you haven't actually noticed, let me go back into Unity real quick and let this compile. We'll go into our gun rig and just look at our muzzle real quick. We actually have an audio source here with the gunshot sound on it, and I've unchecked play on awake and bypass reverb, bypass listener effects, and bypass effects, so that way our sound will play whenever we call it in script. Okay, so there's our gunshot sound, and we also want to say fire counter is equal to 0. So we're going to reset the fire counter, then we'll say Raycast hit, call it hit, and let me just back that back up. We'll say if our player controller.aim, and if we're aiming, then what we want to do is say if physics.raycast, and we're going to perform a raycast with our reticle direction, essentially. So wherever we're actually pointing our reticle. If we're in aim mode, then we'll do our hit detection here, and I'm going to send that out by 100 just for expediency. And if that's the case, then what we want to do is instantiate. We want to instantiate a bullet hole prefab at hit.point and set the rotation, which we're going to use quaternion.from_to_rotation so that we can adjust its rotation appropriately according to the mesh that we hit. And we want to go from vector3.up to the hit object's normal, and that will adjust the rotation appropriately to whatever mesh our ray hits. And if we're not in aim mode, what we'll want to do is say if physics.raycast muzzle.position muzzle.forward. Because we're firing from the hip, we actually want to fire a raycast from the muzzle to the direction, or in the direction of its forward direction. So in the forward direction of the gun, essentially. Then we'll say out hit, collect the hit data at 100 yards. And in here we'll just do the same sort of thing. Well, actually, we will take this right here and just copy that line right down into here. And we'll also want to use our muzzle flash, but what I'm going to do is I'm going to create a coroutine for the muzzle flash just to make it a little bit more efficient. And I'm going to make a private enumerator and call it muzzle flash, and an enumerator expects you to return something. So what I'm going to do is I'm going to say GameObject.go, or GameObject call it go, and that's going to be equal to, and I'm going to cast the instantiate method as a game object, and instantiate the muzzle flash, or muzzle flash prefab at our muzzle.position. And we're actually going to have to, at least for my muzzle flash system, I'm going to have to adjust the rotation in an odd way. Normally you would just say muzzle flash dot rotation, but because my muzzle flash that I'm using from JMO Assets has a very, very odd kind of rotation, so I'm going to go ahead and go into the war effects and I'll just show you what I'm talking about. go into war effects and come into effects, muzzle flashes, and I'm going to be using the rifle 3, or let's see, there's more than what I thought. Let me just plop that in there, and let's see, I'll look at a few different ones, which essentially just kind of looks the same. Okay, so I'm going to be using the 4 planes rifle 3. If I drag this in here and look at it, well, now that I do look at it, it looks like it's rotated in the proper direction. Let me look at, okay, so the local direction is a little bit odd. You can see the Z vector is pointing in the left direction of this right here, and so I actually need to manipulate that in a roundabout kind of way. So for right now, I'm just going to go ahead and stop the particle animation and come back into the code and shut my mouth and just do it. So for the rotation of the instantiated muzzle flash, I'm going to use quaternion.euler, and I want to use the muzzle.eulerangles.x, muzzle.eulerangles.y for the y, and then subtract from that 90 degrees. And then I'm just going to use muzzle.eulerangles.z for the z. Okay, so the instantiation of the muzzle flash is done. Now what I want to do, just to make sure that I don't fire a round while I'm running and then have the muzzle flash just trail off into nowhere, I'm going to set the parent. So I'm going to say go.transform.parent is equal to muzzle. And muzzle is a transform, so that should be fine. And after that, I'm going to yield return new wait for seconds, and I'm going to use go.getComponent and grab the particle system and get the duration property from that. And that, well, that's how long I want to wait. I also want to add on a bunk value of 0.05 to that as well, and I'll actually have to manipulate that particle system to be what I want. But after that, I just want to destroy, go, and now I can actually start that coroutine. So I'm going to come outside of the else statement to see if we're aiming, and I'm going to start coroutine and just call my muzzle flash coroutine. And finally, outside of everything in the update method, I'm going to set the fire counter, or add to the fire counter time.delta time, like that. And so let me go ahead and come back in here. Now I'm actually going to set up my particle system. So I'm going to select that. And first of all, I don't want it to loop. There's no reason for it to loop. Second of all, my duration, I actually want to set that down to 0.10. And that actually looks pretty good right there. So let me stop that and just simulate. And you can see that it just immediately flashes and stops. And that's exactly what I want. So I'm going to change the name of this. I'm going to call this muzzle flash, and I'm going to drag that into my prefabs now. So I'll just come over here and drag this into prefabs right there. And lastly, what we need to do is now we have the ability to instantiate bullet hole effects. We actually need to be able to destroy the bullet hole effects. So what we're going to do is we're going to go ahead and go back into Visual Studio and open up our destroy decal script. And this is a pretty short script. Let me just go ahead and open everything up. And I'll come into my public fields and I'll make a public float. Call that time. It's going to be equal to 5. and I'll make a private float and call that alpha, and that's going to be equal to 1. And I'm actually going to skip the start method, and I'm not going to have any custom methods either, so I'll just get rid of that. Probably get rid of this too. Like I said, this is a very short single purpose script, and all it's meant to do is just destroy the bullet holes. And so in our update method, I'm just going to set our time, or subtract from our time dot delta time. And after that, I'll say if our time is less than 0, then we'll want to do some stuff. So I'm going to set alpha, or subtract from alpha, time dot delta time divided by 3. Then we're going to set or grab the color and call that our color or texture color, and that's going to be equal to renderer dot material dot color. Then we'll set our texture color dot a equal to alpha, and then set the renderer dot material dot color equal to texture color, and let that do that. And then we'll say if our alpha is less than 0, then all we want to do is just destroy our transform dot parent dot game object. And the reason that we're destroying the parent instead of this game object is because we're actually going to put that on the texture object of our bullet hole. So if we take a look at our bullet hole, this is just a regular prefab, and we look down here, this plane is actually what has the material for the bullet hole on it. So what we'll need to do is go into our scripts and take our destroy decal and just put that on the plane. Alright, so now let's go ahead and get rid of this muzzle flash and go to the player, and we'll set up our weapon script. So first of all, it wants to know where our gun rig is, so we'll go ahead and give it our gun rig. And the fire delay, probably going to set to 0.2, at least for now. I'll do 0.2. And it wants to know the muzzle of the gun rig, so I'm going to go ahead and put muzzle right there. It wants a bullet hole prefab, so take our bullet hole prefab, put it right there. It wants a muzzle flash as well, so I'll take our muzzle flash and put it right there. And it wants to know where our camera is, which is right here. So let's go ahead and test it out. Alright, so far we don't have any errors. I'm going to go ahead and walk around, and I'm going to try firing from the hip. And of course, do that. Alright, so it seems to be working. Our fire rate is a little low. Let me go ahead and try looking up and down. And if you pay attention to his arms, let me go ahead and grab the game view, put it right here, and let's click off of him, and I'm going to go into perspective. Now I'm going to move, or go into aim mode, and move up and move down, and we can see his hands resolving appropriately to where we actually rotate the weapon. And there's a little strangeness right there, but I mean, that's really not all that bad. With a few tweaks you can definitely fix that up, and probably a better gun script, but this is just very basic to get everything going. So let me just go ahead and put the game back up here and try out the yep. Alright, so that's all working. Let me go ahead and grab our player, come down to the weapon script, and I'm going to increase this to 0.1 and see what this does. Maybe probably about 0.15 seems reasonable. Alright, so I like that a lot better, and now all I need to do is just change the fire delay to 0.15 and grab our player and apply that prefab, and grab the target, apply the prefab, and just Control S to save. And there we go. So now we have a third-person controller, and I really hope that you enjoyed this and found it informative. And like I said, I definitely do intend on expanding upon this in the future. We're going to have reloading, we're going to have crouching and proning, we're going to have weapon swaps. There's going to be a GUI. Probably wind up using something like Rain AI to create some things that you can fight. There was one request from one of my viewers that wanted a third-person controller using the Photon networking system, so that is the next thing that's on the timeline. We're actually going to make this multiplayer. But that's probably going to be quite a ways in the future. I have a lot of things that I need to take care of in just life itself, so I'm probably not going to be making a tutorial for quite some time, a few months at least. But I hope that this is enough to hold you over till then, and as always, thank you for watching, and I'll see you in a future video.